Well, so in this tutorial we'll see how to create a simple geometry and mesh to simulate the flow around a cylinder. So as you can see in this image, we'll consider a cylinder with radius 1 unit and whose center is located at the 0 point, and we'll have a rectangular domain around it. So we'll have 5 units from the center of the cylinder on the right hand side and the 2 units along the x-axis in the left hand side of the cylinder, and along the y-axis we have 3 units up and down from the center of the cylinder. So let us now see how to create this mesh using Gmsh software. So as you have downloaded this Gmsh folder, you can see the .exe, the executable file. If you double click it, the Gmsh software will open and you can see a already created geometry, but we don't want it, so we will create a new one, and we can name it as cylinder mesh .geo. So take care of this fact that the extension is .geo, which is important for the Gmsh files, and we will use a built-in geometry kernel. So this is the window that you can see where we have to create the mesh. So before creating the mesh, we have to create the geometry as well. So first thing that we'll do is to create the geometry is to add the vertices of the domain and the body. So if you can go to the modules, you will see that there are 2 important modules that we'll use. One is geometry, the other is mesh. So the first one is geometry, and you can see another 2 important options which we'll use. So one is elementary entities, which will take care of all the elements of the geometry, and once those geometry is created, we have to define the physical groups to create the patches where we'll apply the boundary condition. So let us do one by one. So we will first add the coordinate points of the computational domain and the geometry. So we will add the point. So in point, you have to put the coordinates of the vertices that you want to create in the mesh. So the first point that I'll create is 0 0 0, which is the center of the cylinder, and this 1.0 factor is related to the mesh size or the cell size, which we will modify later. So for now, let's keep it default as 1. So let's add it. Then the next point would be, if we see the picture, the next point would be this corner of the rectangles. So what are the coordinates of the corners of the rectangles? So this corner, the coordinate would be -2 -3, -2 3, 5 -3, and 5 3. Okay, right. So let's do that. So -2, so -2 -3 0, -2 +3 0, +5 -3 0, +5 +3 0. Okay, so you can now see that we have the 4 points and the center of the cylinder. For creating the cylinder, let us see how to create the cylinder edge. So for creating the cylinder edge, we will use the circular arc. So for creating, so this is the center of the cylinder. So for creating circular arc, we need two more points which would be on the cylinder surface. So we have to add two more points. So let us add, since you can see that we are considering the radius of the cylinder to be 1 unit, we will create a point at 0, 1, 0 and 0, -1, 0. So let us do that. 0, 1, 0 and 0, -1, 0. Okay, that's it. So all the vertices are so all the vertices are there. Now I will add the circle arc, which is asking to select the start point, then the center point, then the last point. That's it. So this is creating a circular arc for the cylinder. Now we have to select in the other direction. So I selected in one direction. We will select the start point is this, then center point is this, then last point is this, which will considering the other half of the cylinder. So now the cylinder edge is ready. So now we have to add lines for creating the domain. So for creating that, we will add line and we will join one by one. That's it. One line, then other line, then the other line, and then the other line. That's it. So now the very simple geometry is now ready. So in the next part, I will show you how to mesh it. Thank you. Well, so we have the simple geometry here with rectangular domain and the cylinder which we created in the previous video. Now we will see how to use structured and unstructured meshing into it, and first we'll try with the unstructured meshing. So before going into the details, let us first see how the underlying script of Gmsh looks like. So if you go to the folder where you have saved your geometry file, which is cylinder_mesh.geo, if you remember, we saved the mesh in this name, and if we open it with a text editor, we'll see that when we have created the geometry using the GUI, it has also written all these comments underlying in this script. So we will now see if we make how can we make changes in the script and also reload it, which will be automatically implemented into the GUI. So let us add these 2 points with the existing domain, which is 7 -30 and 730. So basically extending a domain in the x-axis, and let us save it. Now if we go back to our GUI, and within the geometry module we have a command called reload script, and if we click that, we will see that those 2 points has been added to our existing geometry. So this is to show that we can do things in either way. We can make changes here in the GUI which will be automatically been written in the script, or also we can go back to the script and write our comments and codes there and reload the script, which will be automatically implemented in the GUI. So alright, so let us go back to the script and let us delete these 2 points for now and save. And if we go back to GUI, and we'll see that if we reload the script, this is gone. Good. Now let us see how do we mesh it using unstructured meshing. So before we go to the mesh, one thing is left to create in the geometry. That is, you have to remember that we have created only edges here. We have to now create the surface, which will be discretized into the mesh. So for that, in the geometric elementary entities, we will go to add, and we have plane surface. So if we click that, we are asked to select the surface boundary. So we'll click on the geometry, it will select the whole boundary. However, it is now asking to select the whole boundary. So that means that we don't want the region within the cylinder to be meshed, because that is an obstruction in our domain. So we want a hole there. So we'll select the whole boundary. Now if everything is done, we'll now press E to accept the changes. Okay, and Q to abort. So I hope the physical surface has been created here. And now if we go to mesh and use 1D and 2D mesh, you can see that our 2D unstructured mesh is created. However, which is very coarse, because we have chosen the mesh size, the cell size to be 1.0, you remember. So we have to modify that. So let us now go back to the script and see what has happened there. So we have to reload it, and we'll see that we have created curve loops and plane surfaces. So now if we change here in the points, as if I choose k equal to 0.2 and I replace all these 1 values by k, let us see how we can refine our mesh. Okay, now we have actually declared a variable k which can be chained and varied to refine our mesh by choosing the cell width or cell size. Okay, so let us save and just go back to the GUI, and by loading, okay, so just loading our script, we see that there are a lot of errors. Okay, so it is showing that unknown variable k. Okay, yeah, so the error was that we forgot to put the semicolon mark. So now you can see that we have refined the mesh. And let us go back and change the k value to 0.1 and save it, and let us reload the script and 2D mesh it. We will see that we have meshed it by triangulation. We have created the unstructured mesh around the cylinder. So one thing is left here now, that how to define the boundary patches. So we have to define the boundary patches where we can actually apply the boundary conditions in the solver. However, we have to remind ourselves that this is a 2D mesh. Okay, so there is no direction in the third direction. Okay, so we have to choose the edges where we can apply the boundary condition. It's not a patch. So we will continue it in the next video. Thank you. Well, so in this video we'll see how we can create a structured mesh around this cylinder as opposed to the unstructured triangular mesh that we have created in the previous video. So for that purpose I have slightly modified the geometry. Now the computational domain is divided into 2 blocks of squares instead of a rectangular one, and the points on the cylinders are also different. Previously I have chosen only 2 points. Now I have chosen 4 points which are connected with the corners of the square. So I hope that you can create this geometry very easily as described in the previous videos, so I'm not going into the details of that. So let us directly go into creating the structured mesh. So first let us look at the script now. So most of the parts of the script are exactly similar what I described in the previous video. The only different thing is here that I have parameterized the points on the circle. Okay, so I have chosen a radius of 0.2 and I have defined 4 different points to be r cos theta comma r sin theta, and based on the value of this theta they fall in different quadrants. So the 4 points 8, 9, 10 and 11 fall in first, second, third and fourth quadrant of the cylinder as can be seen here. So this is the first point, second point, third point and the fourth point, and they are parameterized, so the radius can be changed very easily and we can play around with the diameter of the cylinder as well. So let us now go ahead. So the first step would be now to define the physical surfaces, right? So as described in the previous video, we have to go to the elementary entities, add, and then we have to add plane surfaces, and then we have to add all these blocks separately one by one as physical surfaces. Only thing is that we have to keep in mind that we have to follow a particular convention, like I will do here as anti-clockwise direction to select all the edges to define the surface. So let us start with this block. So 1, 2, 3 and 4, and then press E to accept. So you can see this sign which defines that we have now made it a surface. Okay, so let's follow the same step and do for all very quickly. And then for the last part. Okay, so now you can see that all these blocks, 4 and 5 blocks, are made into physical surfaces, right? So let us look into the script again. So there has been some changes, and yes, so basically you can see that all those surfaces are now defined. So let us quickly delete the unnecessary comment parts. Okay. Good. Now save it. Now The most important thing that is needed to create a structured mesh is to define all the edges as well as all the surfaces to be transfinite. So let us do that. So for that we have to go to mesh, then define, then transfinite, and then we have to choose curve. So here in this curve, 10 number of points means that we want to divide or discretize that edge into 10 divisions, and with a uniform division, a progression of 1, or we can change it to define the grading of the mesh, but we'll do it later. So let us first do for 1. Okay, then E to select. That's it. Now let us abort it and go back to the script and see what changes has been made. So you can see that we have now defined a transfinite curve 10 using progress of 1. So 10 division with progressions of 1. So let us cut it and paste it beside the line number. So that line was marked 3, so it is easy to demarcate, so I am just pasting this here. So instead of doing it in GUI, we can simply copy this and do it for all the lines very easily and changing the number accordingly. So let us do that. So 4, 5, 6, 7. So we have to do it for the circular arc as well. So 8, 9, 10, 11, as well as the internal lines, 12, 13, 14, and the last one is 15. Now let's save it. That's done. So we didn't have to do it for each of these separately. So now we have to do the same thing for the plane surfaces. We have to make them transfinite. For that, similarly, we have to go to transfinite, then surface, and we have to choose the surface like this and E to accept. Okay, now do Q to abort and again go back to the script, and if we reload it, we'll see that exactly they have created a transfinite surface. And let us go and copy paste it to them, and very easily we can make all the surfaces transfinite through the script itself, and we don't have to do it in GUI, which is good. And so we have total 5 surfaces and we made them all transfinite. Okay, so that's good. So these are surfaces. Okay, so let us save them. So now we have made them transfinite, and let us go to geometry, elementary properties, and reload the script. So done. You can see here done reading the geo file. So it's done now. Now, as I mentioned in the last video, that this surface is a 2D surface, so there is no width in the Z direction of the mesh. So what we have to do is, if we want to import it to OpenFOAM, we have to make it a 3D mesh, because OpenFOAM by default accepts 3D meshes, not a 2D one. So for that, what we will do is, we will actually extrude this. So for extruding this, we have to again go to elementary entities, then we'll see there is an extrude comment, and we will translate the whole thing to a value of say 0.01 unit in the Z direction, and we'll do it in one mesh layer, and we want to recombine everything. So, and we'll do it for all entities. Okay, so for that let us select everything now. So we will select all the edges, and all the surfaces as well. Okay, that's it. Then we have to accept E, that's it, and then we will do Q to abort this. Now let us rotate it and see if there is a 3D direction. Yes, there is a 3D direction indeed. You can see the mesh is extruded and it is no more a 2D direction. So let us now go back to the script and reload it, and we'll see that there has been an extrude comment and all these curves and surfaces are chosen and they are recombined as well. So just for the sake of visualization, I just make it as 1, and let's see what happens. So let us save it and reload it. Good. Now let's see. You can see that we have now extruded the whole geometry to 1 unit in the Z direction. So it's a properly 3D mesh now. That looks good, but we don't want that. So we will go back to the script, and we want a 2D mesh, but for the sake of OpenFOAM we are making it 3D. So we'll give a minimum value of, let's say, 0.01, and we will reload the mesh, reload the script, and now we will go to the mesh and we will do meshing. So for the meshing, now since it's a 3D mesh, we have to first do recombine. We can do again by selecting everything we can do. However, I think recombine has been done while extruding, because you remember we have chosen tick the recombine option, so we don't need it. So I think we'll abort it and we'll mesh it as 2D. So if we mesh it as 2D, it's a 2D mesh, but as I said, since it's a 3D mesh, we'll mesh it as 3D also. So now the meshing is done, and you can see that it is a 2D, it's a 3D and structured mesh, which means that it happens through quadrilateral mesh elements and the division between them. So secondary triangulation is there, but it is structured. So now let us look into the script and let us refine the mesh. So as I said, for refining the meshes, I have decided it to be all 10, right? So let us now define another variable like k, which is, let's say, r, which is, let's say, any variable I, and make it now as 100, and I will change all this as I. So that from the next time, if we want to change the refinement we don't have to change all these values, but we just have to change the value of the I, which is more sophisticated and more intelligent thing to do. So let us parameterize it. Okay, and for also for the sake of visualization, let's make it 0.1 and save it and go and reload it. Okay, now do 3D meshing. That's good, that's a very fine mesh, and you can see it's a complete 3D mesh. Okay, so we have now refined the mesh very nicely. So if you want to now know how many cells or how many grid points are there, we have to go to tools, then we can go to the statistics. So it shows total 1 lakh, right? 1 lakh nodes and total 19620 triangles, and all these statistics that you need to know. And in the geometry you have 31 points, 65 curves, 40 surfaces, 5 volumes, right? So you can see the statistics also.